In this video, we're going to talk about how to overcome some template specialization problems and what problems you might face. So this idea of the compiler looking at your template pattern and then how you're using it in the code and figuring out the right way to specialize the template, that's called type deduction. And this is one of the most sophisticated parts of the C++ language. Type deduction logic in C++ follows a best fit principle. You've heard me use this term before when talking about function overloading, where when it's considering a bunch of functions that have the same name, it tries to make the best guess about what the programmer wanted and pick the function that's that seems to fit the best, right? That has the fewest number of type conversions. So it does the same, it has a similar sort of goal when applying templates. And in fact, a significant part of function overloading and type deduction logic overlaps, because a lot of times a template is going to be a function, and it's basically all the different ways you could specialize the function are basically like overloaded versions of the same function, just with different types. So it's always trying to do that best fit analysis. And I'm not going to go into the rules here because they're quite long, quite complicated, and can get a bit confusing. And so that's not the key point of this video, but I'll come back to it later in the semester. Instead, we're just going to stick with that idea of best fit, and we're going to try to keep the example simple so it's kind of obvious what the best fit would be. However, even when we keep the example simple, there are multiple ways the compiler could think that it should specialize a template sometimes. And in these cases, just like with ambiguous function overloading, what the compiler tends to do when it's not sure is it raises an error. And then at that point, the programmer has to help out by modifying the code. Okay, so when there are multiple ways the compiler could specialize something, normally at that point, the compiler has, the programmer has to get involved to help the compiler. Okay, so what are some examples of template specialization problems? One of them is when the types in a template cannot be specialized consistently. We're going to take a look at that right now. And another is when an object is lacking functionality, like an overloaded operator, to make the template work. So let's say I'm calling the max function, right? And this type name t means that we can pick one type to substitute in for t. Everywhere we see t, it needs to be an int or a double or a character or a complex number that we've implemented as an object or something like that. So down here, this call in main, inside printf, I'm calling max, and the first argument is 3.14, and the second argument is 55. Now, according to the typing rules in C++, 3.14 is a double, and 55 is an int. And so then the question becomes, is t equal to int, or is t equal to double? Which way should the compiler specialize this template? And the problem is it's inconsistent, right? Depending on which argument it looks at, it would make a different conclusion. And the answer actually is important, because if it chooses double, you're going to get one answer. If it chooses integer, you're going to get a different answer, right? So there's no good choice here. It's not like they both lead to the same answer. So this is confusing, and the compiler is going to generate an error here. It's going to say syntax error deduced conflicting types for parameter t, int versus double. Okay, exactly what we said. We knew it was taking an int and a double, and the compiler doesn't know which to pick. And so the thing is, the types here have to match. The template says the two arguments have the same type. And if they don't, then we violated the rules for using this template, and we have to fix it. So they either both need to be int or they both need to be double. That's kind of an easy thing for us to fix. What I could do is, like, if I really want them to be integer, I could come in here and I could add a cast onto my 3.14 and force this to become an integer. It's kind of, with a constant in the code, I could just edit the constant to be 3, right? That would be another solution. But if this were a variable that was of type int, of type double, then I might have to do a cast to turn it into an int. And then this forces the compiler to conclude that the type should be int, that t should be int, and then it'll know how to call the template properly. That's one way we can fix it. Another way we can fix it is by explicitly specializing the call. Basically, after this name, max, since max is a template, we can tell the compiler what we want it to deduce by putting the name of that type in brackets. So I have max, less than, int, greater than. It doesn't mean less than and greater than. Those are just the symbols, right? It's just the brackets telling us what t should be interpreted as. And then the compiler knows, oh, t equals int, and then it will force a cast on this double value to integer, and it will generate the function assuming integer types. This is called explicit specialization, because rather than letting the compiler choose the specialization, the programmer is forcing the specialization to be int. So this is another way we can deal with this problem of the compiler not knowing what to do. We can force it and tell it exactly what to do. Give it the specialized type up front. Now, there's another set of options we could go down and explore, and that is we could actually have multiple template arguments. I could make my template more configurable for the compiler. I could say that it takes in two types, a type named T and a type named S, and that one of the arguments is T and one of the arguments is S, is type S. And this could help, and this could work. And in this case, it could look at these two parameters and conclude that T is equal to double, S is equal to int, and then anywhere I see T in this code, it's going to be a double, and anywhere we see S, it's going to be an int. And now what we're going to see here in this code is that the return type is S. And so I'm going to return an integer from this function. But is that really what I should have? Should I always match the second argument? It's a little bit weird, okay? It's not really clear that my return type should be forced to be T or S. But it's also not clear if it's not, T or S, what it should be, because it can't be both T and S at the same time. What the template means is that I have to pick a type, right? And even if I could add a third type here, let's call it, R for return. Even if I added a third type here, what should it conclude? Because I return A and B, and if I got rid of this cast to S in my template, what would R be? Should it be int or should it be double? And what should the compiler pick? Well, there are ways to get the compiler to help us pick a return type, but they're more advanced than I want to talk about right now. So I just wanted to bring this up. Sometimes, like we can even generalize our template more to try to handle more cases, but it might introduce more problems. So really one of the previous two things we did is really better in this case. Now, I alluded to this at the beginning. I might want to specialize my template using a class, right? And the question is, can I do that? And the answer is I absolutely can. T could be a class. In fact, it could be our complex number class that we implemented a couple of weeks ago. The only thing we have to be worried about is all the code in this function compatible with whatever class we pass in? And if we look carefully, we would say, well, if I'm returning an object of that class, then I need to be able to copy it. So it had better have a copy constructor that's available for use. But another thing we'll notice is that I need to be able to do a greater than comparison. A greater than B needs to be legal on the type that we specialize for, which means if it's an object, if it's a class, it needs to have an overloaded greater than operator. And if it has that overloaded operator, then this will work. But if it doesn't have that overloaded operator, a specialization will fail to compile. You'll get a syntax error. You'll actually be able to specialize, but when the compiler tries to generate the code specialized on that object, it'll realize there's no appropriate greater than operator, and it's going to fail to work properly. And it's going to give you a syntax error. Okay, so in addition to that, let's just look at an example. I could create some class called SumInt, and then inside SumInt, I have an integer x that's equivalent in meaning to SumInt, and then I define on SumInt an operator greater that'll tell me if which object is greater, either the object this operator is called on or the object it's called against. And as long as I define this operator, if I pass a couple of SumInts into max, then the compiler will be able to specialize it properly. So that's pretty cool. And now I've written one version of this max function that works on doubles and integers and characters and even works on objects that provide that operator greater than. Okay, so in summary, there are times when the compiler cannot deduce the specialization for a template, and we have to step in. And we can fix it a variety of ways. We can use casting to force an argument. If multiple arguments don't match, we can use casting to force them to match. We can use explicit specialization to tell the compiler exactly what we want it to do. Or we can even redefine or extend the template to make it work better in all the circumstances we want it to be applied to. Specialization using classes also works, but you have to be careful to make sure that all of the operations you do in the function are supported by the class. And in particular, this might mean needing to implement certain special member functions, like a copy, or implementing a special operator, like a greater than operator.